Well, a little bit of history. When the art of making motion pictures began, there was a lot of different standards being produced. One film didn't work in another projector, and there was a total incompatibility with all the different film formats. Obviously, television hadn't been invented yet, but there was a major problem of trying to interchange films because this camera film that was exposed to a negative couldn't play in this projector. So there was an effort made by our founder, Mr. Jenkins, to come up with a standard to unite this diversity and allow the content to be widely distributed. And that was the genesis of it. As television came along, the need for having common standards to allow us to exchange programming became very, very important. And the Society of Motion Picture and Television Engineers has standardized a lot of the production and distribution methods that are in use today. And this enables us to exchange content on a global scale so that we can exchange art and thoughts and creativity. We are the tool makers that create the tools that allow the creatives to tell the stories and express their motion picture art in a way that suits them. So whether you're talking about our now electronic digital cinema, since we're distributing movies around the world and in the United States electronically to electronic projectors, this really enables us to exchange programming freely. And once you have a common global standard, it really makes for a global village for exchanging culture, ideas, and art.
How SMPTE managed to take a standard that was American, that was in the United States, and turn it global? Remember that at that time, in 1916, we had a strong film industry in France, in Denmark, and in Russia, for example. So Germany, many countries had a strong film industry at that time. How did you manage that?
I think because we look at our organization as really not just a domestic U.S. organization, we looked at it as a global organization. And many times you had filmmakers that had the same common problems, whether they were in France or Germany or Russia or Brazil. They had a common set of technical problems that they were trying to solve. And we saw it as a way to unite everyone together to come up with a common methodology so that if you solved the problem once in America or you solved it in Brazil, you now had a solution that worked on a global scale and you didn't have to solve the problem in every country. So that was, I think, the genesis, and this also was an economic benefit for the companies. They didn't have to worry about a different film format in a different country. If they could produce the program once and distribute it many times, that meant that helped their costs to be low, and it helped them to further their business by having a common standard. So it was an economic benefit for them to try to find a solution that was common to everyone.
How about the 35mm format? Do you know how did it came along with the 35mm format as the standard?
Part of this, I think, was there was a whole host of standards, and as the screens got bigger and bigger, people realized they need more quality, because they initially were using 16mm quite a lot. That was widely distributed, but as the screens got bigger and the audiences became more sophisticated, then Kodak developed the 35mm format, which really became the world standard. Interestingly enough, when we went to electronic acquisition with electronic cameras, the sensor size was still approximately 35mm. So for a cinematographer, a director of photography, transitioning from film to a digital cinema camera, it was very easy because it was the same image format for them. A lot of their lenses that they used for 35mm film would work on a digital cinema camera. So for them, they didn't have to learn a whole new trade and a whole new art. They could bring some of the knowledge that they had developed in the film and move it into the electronic domain.
When TV appeared, what were the problems with formats that had to be issued by SMPTE?
Well, for example, when we first started to do videotape, we had one videotape standard that was a 2-inch videotape, and everyone was using it. People said, okay, what's the next generation of tape machine? And they came out with a 1-inch tape, except there were different varieties. There was the Type A standard and the Type B standard, and people said, we can't interchange programs freely. We need a common standard. So SMPTE stepped in and created a new standard that was common called the SMPTE Type C tape format standard, and that then allowed the business to flourish because everyone had a common tape machine and they had a common way to exchange programs between them. We did the same thing with high definition. When high definition was in the early stages, Europe was doing something different. Something different was happening in Japan. So SMPTE came together and working through the International Telecommunications Union, which is the technical arm of the United Nations, was able to get recommendation 709 through the ITU. So now the high definition standard became an international standard. So now you could exchange programs in high definition electronically. So this was a major milestone because everyone that adhered to that could buy a common set equipment. So instead of just looking at the economies of scale for a domestic market, a manufacturer could now sell equipment on a global market that was totally interchangeable. And so they could sell many more units, so the unit price came down for the cameras and the tape machines and everything else related to high definition. And today, high definition is still used for photography in Hollywood, and in some cases has become less expensive than 35mm film.
What about spectrum? We have different systems of transmission of open TV, even today around the world. How SMPTE has worked with this kind of issue, specifically the spectrum, the use of a spectrum?
SMPTE, Society of Motion Picture and Television Engineers, really concentrated on the production side and has not really gotten into the spectrum issue. We felt that that was an individual country's decision to make, their government to make, and therefore we had to come up with common video and audio standards that would work in all of those distribution methods. So this is why the ITU recommendation 709 was so important. It was a common video format for high definition, and it allowed us to exchange the video, and it didn't really care about what the spectrum modulation and transmission method was. So Japan could do something differently than Brazil, than the US, so it wasn't an issue of transmission. It was making sure that the content had a common video and audio format.
What about today? What are the challenges SMPTE is facing, and what is next in the near future?
One of the things that we're working on that is of extreme interest to the industry right now is we're looking at delivering audio and video over Ethernet cables, using Internet Protocol or IP protocol. So you'll now be able to take video and audio and put it onto an Ethernet cable and distribute it on a global scale. So SMPTE is coming up with a common standard. It'll be called SMPTE 2110, and this will be a way for people to exchange high-quality video programming real-time on the Internet using IP protocol, Internet Protocol. So we've been working very hard. We hope to have that completed by the end of this year. And people are already doing tests and trials and interoperability, plug fests as they call it, to make sure that everything plugs and plays together. So that's, I think, a next milestone for the industry is video over IP.
We have, on the contrary of 100 years ago, today we have not only the big studios making movies, the big television channels making content. We have also small producers, even amateur producers. Everyone can upload content to YouTube and other platforms nowadays. Does this platform also take into account these people, the consumer and also producer of its own content?
I think it does. The IP over video standard will allow anyone to really exchange programming. We've seen companies like Netflix, which you consider an OTT company, now entering into first-run original production. They, for example, came to SMPTE and said, we need a global intermediate mastering format because we need to bring programs in from all over the world. We then have to input them into the system and then distribute them. So the SMPTE IMF format was a way to allow a company or a broadcaster to have a common format and then have different languages. So you might want English and Portuguese or Spanish and Portuguese, and by selecting from a list of languages that were associated with that video, you could customize the delivery package for that particular country. This is very important because you take any of the major studios, they might deliver 400, 500 different versions of the same movie, and that is very labor intensive. So having a way to automate that and easily distribute the files to all of these countries is very important. And that's what the IMF format that SMPTE developed has done. The IP format that we're developing, SMPTE 2110, will be a way to deliver audio video in real time.
Great. Well, just to finish, 100 years is a huge milestone.
Yes.
And in your opinion, what's the secret of SMPTE success?
I think the success of SMPTE is due to the collaboration of the engineers that realize whether you work for ABC or NBC or Disney or Universal, you're not competing on technology, you're competing on content. So the engineers from the industry and the manufacturers come together in a very collegiate atmosphere to work together to solve a common problem, because we all realize that if we solve the common problem, it's going to benefit everyone. So it's this collaborative effort that occurs in the engineering standards committees that's so impressive, and I think will go on for many years to come as long as we can have that cooperation.
Thank you very much, and congratulations, Mr. Siedel.
Thank you very much. It's a pleasure.